The ATR landing gear is a retractable tricycle fuselage-mounted type. The landing gear consists of a forward retracting nose landing gear, NLG, and two retractable main landing gears, MLG, mounted partially on the side pods and partially on the fuselage. They are electrically controlled and hydraulically actuated. Each main gear assembly has an oleo-pneumatic shock absorber. And is equipped with two wheels. Each main wheel is fitted with brakes and anti-skid. The nose landing gear assembly includes two wheels, an oleo-pneumatic shock absorber, and a nose wheel steering system controlled by a steering hand wheel located on captain's side. The main landing gear retracts inboard, partially below the passenger compartment floor and partially into its fairing. The nose landing gear is forward retracting. It is housed in its wheel well in the aircraft nose. The main landing gear has a three-section door. The door's upper part is hinged to the fairing, and its lower part is attached to the main landing gear leg. When closed, the main landing gear doors restore fairing contours. The nose landing gear carries mechanically connected doors. When closed, the nose landing gear doors restore fuselage contours. A non-retractable tail bumper is installed on the rear section of the underbelly. It prevents the fuselage from any friction with the runway when the takeoff or landing pitch attitude is equal to or greater than 8 degrees. The tail skid is attached to the fuselage by a shock damper. The tail skid is equipped with a stainless steel plate, the skid shoe. The shoe has a red paint undercoating to indicate visually, when missing, any contact with the runway. This indication provides the pilots with visual runway contact indication during pre-flight. If, during pre-flight, the pilots notice any friction exposure on the skid shoe, they must also check the limit stroke indicators. If red paint is missing, a maintenance check has to be done. If not, the aircraft can be considered airworthy. To avoid aircraft tilting backward during passenger boarding or disembarkation, a tail prop must be installed on the tail skid. When not in use, the tail prop is stored in the rear unpressurized area of the aircraft. The ATR landing gear is electrically controlled and hydraulically actuated. Landing gear extension and retraction is commanded by a control lever located on the center instrument panel. The position of this lever is sensed by the multifunction computer, MFC, which in turn electrically controls the landing gear selector valve located in the left-hand main landing gear fairing. For more information about the landing gear selector valve, click on the button at the bottom right of the screen. Each landing gear has its own actuator. The actuators are two-way hydraulic cylinders connected between the leg struts and the aircraft structure. By retracting or extending, they move the gear up or down. When the gear actuator is pressurized in one way, the main gear is pulled up laterally. When it is pressurized the other way, it is extended. The same mechanical actuation operates on the nose wheel. When not in transition, the landing gear is locked in the up or down position. Each gear has a roller pin. And an up lock box. When retracted, the landing gear is held in position by the up lock box locked on the roller pin. The nose landing gear up lock box is in the nose wheel well, and the main landing gear up lock boxes are inside gear fairings. The gear locking is mechanical. A switch in each lock box is actuated when the landing gear is up and locked. Contacts send information to the MFC1 primary and MFC2 secondary circuits of the landing position indicators. Unlocking is done hydraulically when the hydraulic unlocking actuator is powered. Gear down locking is achieved by a folding side brace and locking springs. The springs ensure gear down lock, even if hydraulic pressure is unavailable. Unlocking is done hydraulically by the unlocking actuator. When the gear is extended, the down and locked position is confirmed by proximity switches mounted on each gear. The proximity switches are paired. In each pair, one switch sends information to MFC1 and the other sends information to MFC2. Each switch has an associated target. The proximity switch senses its relative position to the target. When the switching point is reached, about 0.1 inches, the information is transmitted to the MFCs. The MFCs display the status through the landing gear indicator panel in the cockpit. For normal landing gear operation, the landing gear selector valve supplies hydraulic pressure from the green system to the extension and retraction lines feeding the gear hydraulic actuators. For landing gear extension, the landing gear lever is set to down. The landing gear selector valve downside solenoid is powered. The gear extension hydraulic line is supplied and the retraction line is connected to the hydraulic tank return line. For landing gear retraction, the landing gear lever is set to up. The landing gear selector valve upside solenoid is powered, the gear retraction hydraulic line is supplied, and the extension line is connected to the tank return line. Note: the main gear wheels are automatically braked as soon as the lever is selected up. When the gear is locked in the selected position, hydraulic pressure is released from the connecting lines. In the event of normal system failure, the landing gear can be extended manually. In the flight compartment, a push or pull handle will act mechanically on the hook, allowing it to be set in open position. The landing gear extends due to gravity and aerodynamic forces. Main landing gear extension is assisted by a gas actuator. Nose landing gear is assisted by a mechanical device. It is installed on the wheel well sealing. The lever pushes the leg on the towing lug, helping the free fall during the initial phase only. In normal operations, landing gear extension and retraction is performed with the landing gear control lever, located on the center instrument panel. The lever must be pulled out prior to selecting one of the two possible positions. Up, the landing gear retraction is selected. Down, the landing gear extension is selected. The lever is equipped with an electric lever latch, preventing the up position selection when MFCs detect the aircraft on ground. At least one gear shock absorber must sense weight on wheels. Gear handle red light illuminates when any gear is not sensed down and locked with radio altitude less than 500 feet with flaps 30 degrees, or when one of the two power levers is in idle position with radio altimeter below 500 feet and gear are not seen down locked. Landing gear not down alert is displayed on the engine warning display EWD. In case of hydraulic or electric failure, the landing gear can be extended by gravity. Emergency landing gear extension is controlled by the landing gear emergency handle, located on the rear part of the center pedestal. Pulling this handle above the pedestal will mechanically unlock the landing gear and allow its gravity extension. Indications on the landing gear are given by two independent indicating systems. One above the landing gear control lever and one located on the left part of the overhead panel. Primary landing gear indicator is controlled by MFC1. Green light, down lock is engaged. No light, up lock is engaged. Unlock red light, gear is not in selected position or up lock box is not opened on ground. When aircraft is battery powered, the primary landing gear indicator only is available. Secondary landing gear indicator is controlled by MFC2. Green light, down lock is engaged. No light, up lock is engaged. Unlock red light, gear is not in selected position or up lock box is not opened on ground. As the secondary landing gear indicator is electrically supplied by the DC bus 2, the gear status is not available when the aircraft is on battery power. Gear must be considered down and locked when at least one system indicator shows 3 greens. However, if both system indicators are in agreement, the corresponding gear must be considered as not down and locked. Landing gear hydraulic power is supplied by the green hydraulic circuit. In case of failure of the green system, the landing gear can be supplied by the blue hydraulic system through the cross-feed valve. For more information about the cross-feed operation, refer to the corresponding chapter. Landing gear indication on AC Wild and Hydraulic system display page is white when normal retraction extension is available. When the green hydraulic pressure drops below 1500 psi, the message is amber. Only emergency extension is available. In case of invalid data from the landing gear, a cross is displayed in place of the landing gear tag. The nose wheel steering system, powered by the blue hydraulic system, consists of the following main components: a hand wheel mechanism mounted on the captain's lateral console to allow pilot steering control, a nose wheel steering switch located on the left-hand panel, which de-energizes the steering solenoid valve during towing, a swivel selector valve which starves the hydraulic pressure if nose landing gear is not in down position, a steering control unit which receives pilot and feedback inputs to pressurize left or right chambers of the actuator, a steering actuator with 2 anti-shimmy valves, a solenoid valve located in the hydraulic bay of the aircraft. It prevents system actuation if the aircraft is not on ground. This information is given by the multifunction computers. The steering system, hydraulically supplied by the blue circuit, allows the nose gear wheels to be steered during taxi or ground maneuvers. The maximum right or left deflection angle is 60 degrees. The steering system also has an anti-shimmy function, which ensures a damping action in order to keep the nose gear wheels aligned at high speed. On ground, nose landing gear wheels can be turned to the left or right up to 91 degrees, providing the nose wheel steering switch is set on off position. The nose wheel steering system is controlled through nose wheel steering switch and hand wheel. The hydraulic pressurized fluid moves an actuator on nose landing gear leg strut, which transmits the torque to the turning tube through a rack pinion mechanism. Two torque links connect the turning tube to the axe to drive the wheels when the steering is actuated. Feedback links on the turning tube cancel the pilot input to the control valve when the selected turning angle is reached. If the blue system is lost, the aircraft can be guided using differential braking and engine thrust. An internal mechanism returns the wheel to the centered position when the aircraft is airborne. Nose wheel steering is available before takeoff as long as at least one gear is on the ground, and at landing when the nose landing gear is downlocked and the nose landing gear and main landing gear shock absorbers are compressed. Nose wheel steering is achieved by a servo mechanism mechanically controlled from the flight deck. It is manually controlled, hydraulically actuated, and electrically disabled. The steering control wheel is mounted on the captain's lateral console. A nose wheel steering guarded switch mounted on the captain's lateral console allows deactivation of the steering system for aircraft towing. The steering hand wheel can rotate 112 degrees on each side from the center. A push-to-torque switch is located on the hand wheel for communications. A spring assembly ensures the centering of the hand wheel when it is released. No pilot inputs. The System Display AC Wild and Hydraulic page gives information on the nose wheel steering system status. The nose wheel steering tag is indicated on the blue hydraulic system side. Indications on steering status are displayed on the EWD and the System Display AC Wild and Hydraulic. In normal conditions, the nose wheel steering indication is displayed in white. When the nose wheel steering switch is set to off, or if the blue hydraulic pressure drops below 1500 psi, the message nose wheel steering is displayed in amber on the EWD and the system display to indicate that steering is not available. In case of invalid data from the steering system, an amber cross is displayed in place of the nose wheel steering tag. Note: when steering is available, no message is displayed on EWD. The four main gear wheels are equipped with multi-disc carbon brakes. The main landing gear wheels are automatically braked when the landing gear control lever is set to the up position. The nose landing gear is not braked. Each brake is operated by one set of 5 hydraulically powered pistons and is equipped with an automatic adjuster, a wear indicator pin, and an overheat detector. The wheels are fitted with tubeless tires. Each wheel has an inflating valve to fill the tubeless tires with nitrogen. The main landing gear wheels are fitted with pressure release fusible plugs to prevent tire and wheel burst in case of wheel overheat. The plugs release tire pressure when the wheel temperature exceeds 177 degrees Celsius. Two braking modes are available. Normal braking, supplied by the green hydraulic system and controlled by the pilot brake pedals. The pressure applied to the brakes is controlled by an anti-skid system to prevent wheel lock. Emergency and parking brake, supplied by the blue system and directly controlled by the emergency and parking brake handle. The emergency and parking brake is independent from normal braking. No anti-skid protection is available with emergency braking. The normal braking system uses the following components: a reservoir installed on the forward bulkhead, which supplies hydraulic fluid to the master cylinders. 4 master cylinders linked to the pedals, 2 on captain side and 2 on the first officer side, which pressurize the fluid to the reservoir. A metering valve installed in the hydraulic bay left fairing. It uses the pressure generated by each cylinder, right hand or left hand, to meter the pressure to the right hand or left hand line of the anti-skid module. The anti-skid system is composed of one electro-hydraulic anti-skid module with 4 fusers in the hydraulic bay. The fusers prevent hydraulic fluid loss in case of a hydraulic line rupture. 4 wheel speed transducers. One anti-skid control box located in the avionic bay. The anti-skid system is provided as soon as the gear is down and locked, and as long as the aircraft wheel spin speed exceeds 10 knots. The aim of the system is to provide the maximum stopping performance by controlling brake pressure in order to minimize wheel slip, brake and tire wear, depending on runway conditions. A reference velocity signal is calculated. The anti-skid applies a deceleration law, continuously adapting the actual wheel speed to the reference speed. The speeds between right-hand and left-hand inboard wheels and between right-hand and left-hand outboard wheels are processed. Above 23 knots, if there is a differential of 50% or greater between the 2 speed signals, the system generates a locked wheel signal and brakes are released. The anti-skid system also provides touchdown and locked wheel protections. At touchdown and main landing gear strut compression, the brakes are inhibited for 5 seconds, or until wheel spin speed is above 35 knots. This prevents brake action before the wheels have started to spin up on low-friction pavements, slush, gravel, rubber deposits on wet runway. As seen previously, protection against locked wheels is active for wheel speeds above 23 knots and prevents tire scuffing. When electrical supply is lost, the anti-skid is lost and brakes are directly controlled by the pilot's action on the brake pedals. The emergency and parking braking system is composed of a handle mechanically connected to a push-pull cable to the parking and emergency braking metering valve, PEBMV, a parking and emergency braking accumulator located in the hydraulic bay and containing hydraulic fluid under pneumatic pressure. 3000 psi. Action on the emergency and parking brake lever is transmitted to the PEBMV by the push-pull cable. The PEBMV applies pressure to the brakes using the pressurized hydraulic fluid from the accumulator. Even with failure of both blue, green and auxiliary hydraulic sources, the parking and emergency brake accumulator allows 6 complete braking applications. Caution: emergency braking has no anti-skid capability. Normal braking is controlled by the pilot brake pedals. Emergency and parking brake is controlled by the emergency and parking brake handle. The ATR 600 system display AC wild and hydraulic page gives additional information on the brakes and anti-skid system status. The normal braking system is supplied by the green hydraulic circuit. Normal brake indication on AC wild and hydraulic system display page is white when normal braking is available. When the green hydraulic pressure drops below 1500 psi, the normal brake indication becomes amber and only emergency brake is available. In case of invalid data from the braking system, a cross is displayed in place of the normal brake tag. The emergency braking system is supplied by the blue hydraulic circuit. Emergency brake message is displayed white when the emergency brake accumulator pressure is above 1600 psi and parking emergency braking is available. When the emergency and parking accumulator pressure drops below 1600 psi, the message is amber. When invalid, the pressure value is replaced by an amber cross. In addition to the information displayed on AC wild and hydraulic system display page, braking messages are displayed in the flight control window of the engine warning display. The first line displays system faults. The amber "Use emergency brake" message indicates that the green hydraulic pressure is below 1500 psi. The amber "Emergency brake low pressure" indicates that the parking and emergency accumulator pressure is below 1600 psi. The second line is dedicated to the amber "Parking brake on" indication displayed when the parking brake handle is not in the off position. Emergency brake and parking brake are controlled by the emergency and parking brake handle. The handle is spring-loaded to the off position. During emergency braking, pulling the lever gradually backwards along the emergency range allows metering of the hydraulic pressure applied to the brakes and to control braking action. When the handle is in the parking position, full hydraulic pressure is applied to the brakes. A notch keeps the handle in the parking position. The handle is moved to the left to be set in or to be released from the parking position. Parking brake on message is displayed in amber in the flight control window any time the parking handle is not in brake off, fully released position. Caution: anti-skid is not active when using the braking handle. Note: in case of hydraulic power failure, the brake accumulator allows at least 6 braking applications using the emergency and parking brake handle. In addition to the parking brake on annunciation on EWD, and the parking emergency braking accumulator displayed on MFD AC Wild and Hydraulic page, the aircraft is fitted with a parking emergency braking accumulator pressure indicator located on the left maintenance panel. This indicator is used by maintenance personnel when MFD are not powered and in case of main indication loss. When the switch is activated, the indicator is energized for 2 minutes. When the hydraulic pressure of the accumulator is below 1700 psi or above 3100 psi, the indicator blinks in green. Brake accumulator hydraulic pressure is displayed in green. The displayed value has to be multiplied by 1000, as described by the legend on the front face. If a takeoff configuration test is performed or if a takeoff is attempted, with the emergency parking brake set to anything other than brake off, parking brake on message remains displayed in the flight control window of the EWD, and a configuration alert is triggered by the flight warning system, FWS, with master warning and configuration message displayed on the EWD. The anti-skid control panel is located on the central instrument panel just above the landing gear selector and indicator. It includes an anti-skid push-button switch and a test push-button. The normal position of the anti-skid push-button is depressed. In this position, anti-skid is active when the landing gear lever is selected down. To select the anti-skid off, the push-button is released. Off-white is displayed on the push-button. The anti-skid test push-button, when depressed, performs a test of all anti-skid modules for 6 seconds on ground and 3 seconds in flight. Simultaneously, a master caution is triggered and wheels A skid is displayed on the EWD. Cyan A skid test associated with its result are displayed. There is a test on each channel, 2 per main gear, for a total of 4 channels. Amber F is replaced by a green N when no failure is detected for the corresponding wheel anti-skid. 4 Ns indicate that anti-skid system is fully operative. Master caution lights are switched off and wheels A skid caution is removed from the EWD, indicating a pass result. An amber F indicates that an anti-skid failure is detected on the corresponding channel, wheel, and master caution light and wheels A skid message remain displayed. The system is considered as fully failed as soon as one module or more is faulty and must be switched off. According to Airplane Flight Manual, weight abatement, accelerate stop, and landing distance increase must be considered. Note, the anti-skid test is inhibited for wheel speeds above 17 knots. The brake's temperature is monitored. Whenever a brake over temperature is detected, temperature greater than 150 degrees Celsius, a wheel's brake hot message is displayed on EWD. The brake overheat detection system can be tested using the brake temperature push-to-test push button located on the right-hand maintenance panel. As long as this test push button is depressed, flight warning system is activated. Let's perform an anti-skid test on ground. The pilot depresses the anti-skid test push button. Cyan A skid test and 4 amber Fs are displayed on the flight controls window of the EWD. Simultaneously, a master caution is triggered and wheels A skid is displayed on the EWD. During the test, all channels show an amber F for 6 seconds, 3 seconds in flight. After 6 seconds, amber F is replaced by a green N when no failure is detected for the corresponding wheel anti-skid. 4 Ns indicate normal anti-skid operation. Master caution lights are switched off and wheels A skid caution is removed from the EWD, indicating a pass result. If initiated on ground when brake pedals are depressed, the test duration is sufficient to allow observation of the brake compression and release, thereby allowing system verification to be performed. Caution: do not perform the test on the ground, engines running, without parking brake set. Note: the test is inhibited when wheel speed exceeds 17 knots. For information about landing gear limitations, refer to the Flight Crew Operating Manual FCOM 2.01 Limitations. In case of landing gear system failure, refer to the Master Minimum Equipment List MMEL 32, page 1.